Hey everyone, it's Review Unit 12 Circles. Number 1. Given triangle CED is circumscribed about circle A. So remember, circles are named by their center. That means A is the center of the circle, and circumscribed means that the triangle is around the circle but touching on each of the vertices, which means that CF and CB are tangents. So when they tell you that CB is 10, tangents that are drawn from the same external point are congruent. So if CB is 10, we know that CF is also 10. Line segment CF is also 10. And then when it tells me that segment EF, where is that? EF here, is 8, I also know that the tangent drawn from the same external point is also going to be 8 units. So it says part A, and also, while we're on the subject here, we know that segment DG is going to be congruent to segment DB, but we don't know anything about those yet. So let's get to part A. It says angle CDE. We have to find it. Well, remember back here, we were given triangle CED. Well, we know that the three angles of any triangle, the triangle sum of the interior angles is equal to 180 degrees. So we have 2 out of the 3 angles. So it's going to be 180 minus 70 plus 40, or however you want to think about it. So 70 plus 40 is 110, and 180 minus 110 is 70. So that means that this angle is 70. Oh wow, look at this. 2 angles that are 70 degrees. Look what we just saw. We just formed an isosceles triangle with 2 congruent angles, which means the sides across from those angles, this side, CE, is going to be equal to side ED. Not sure if we need that, but let's write that down. Side CE is going to be congruent to side ED. Okay, moving on. Segment CF. Where is that? Segment CF. Oh, right. That's right over here. We said that was equal to 10 because tangents drawn from the same external point are congruent. Then they're asking for segment EG. EG is here. Oh, right. We said that this is 8 for the same reason, right? Tangents drawn from the same external point are going to be congruent. Then they asked me to find the length of segment ED. ED. So, that's going to be the length from here to here. And oh, wow, we did need that information. Didn't we say that segment ED is equal to segment CE? Segment CE was made up of tangent 10 with a length of 10 and a tangent with a length of 8. So therefore, segment ED is going to be 8 plus 10, which is 18. Awesome. Let's move to the next one. Number 2 says determine the value of x in the circle. Well, this angle is an angle formed by 2 chords, and it's in the circle but not at the center, which means we're going to add the 2 intercepted arcs and divide by 2. So I just wrote that out. An angle formed by 2 chords in the circle but not located at the center. We're going to take one intercepted arc of 70 and its vertical angle's intercepted arc of 100, and we're going to divide that by 2. So we end up with 170 divided by 2, which gives us 85. Next, they want us to determine the value of x in circle A. Well, this is an angle located outside the circle. There's actually 2 ways of doing this, but this angle is an angle formed outside the circle is equal to the major arc minus the minor arc divided by 2. So this is the minor arc, which is less than 180 degrees. So now we need to find the major arc, which is going to be the rest of this circle. So in order to do that, a circle contains 360 degrees from one starting point all the way around back to that starting point. We've used up 140 degrees, which leaves us with 220 degrees for the major arc. So to find x, we're going to take 220. We're going to subtract 140, divide that by 2. So that becomes 80 divided by 2. So the angle of x is equal to 40 degrees. This is a special angle. It's an angle formed by 2 tangents, and it's supplementary to the minor arc. So you could have done 180 minus 140 and still gotten the same answer. So a lot of different ways to do these problems. You just have to show all your work. Example number 4. Given the circle below, segment CF is 7, segment FB is 6, segment DF is 3, and it says determine the length of ED. So they want us to determine the length of the entire segment. Well, step 1, we're going to find the length from F to E. And the way that we're going to do that is we're going to take the length of CF times the length of FB. It's the part of one chord times the part of the other. And that's going to be equal to multiplying the parts of the other chord. So that would be segment DF times FE. So we're going to start out with 7 times 6 equals 3 times X. 7 times 6 is 42. That's equal to 3 times X. The opposite of multiplying is dividing. And 42 divided by 3 is 14. So that's equal to FE. So when they ask us to find the length from D to E, DE is formed by segment DF plus segment FE. So segment DE is going to be equal to 3 plus 14, which is 17. Great job. Let's go to the next one. Number 5. In circle O, which means O is the center. So we'll label that O. Secant ADB, secant's line segment ADB, and line segment AEC are drawn from external point A, which means A has to be here. So this first secant is A here, the outer point, D, right? So those letters are going to go in order. And the other secant is A, drawn from the external point. This will be E, and this point will be C. Such that points D, B, E, and C are on circle O. If the length from A to D is 8, and the length of AE, right over here, is 6. If BD is X, well, right away, if that part is X, then I know that the whole secant is going to be X plus 8. And the length of E to C is X plus 12, and right there I'm going to say the whole secant is going to be X plus 12 plus 6, or X plus 18. Determine the length of BD. So they want us to find X. So in order to do that, we're going to take the whole secant and multiply it by its external part. And that's going to be equal to the other whole secant times its external part. Okay, so the whole secant AB times the external part AD is equal to the whole secant AC times its external part AE. So now we're just going to plug in. We have X plus 8 times 8, but I'm going to put the 8 here in the front, right? Multiplication is commutative. I can write it either way. And the other side of our equation is segment AC, which we said the whole segment. Remember, we added those two pieces together to get X plus 18 times AE, which is just a single digit. So again, I'm going to put the 6 in front just so it's easier when I now distribute. So 8 times X is 8X, 8 times X, and 8 times 8 is plus 64, and that's equal to 6 times X, or 6X, and 6 times 18, which is 108. Now, there's four different ways to start this. I like to have all my X terms on one side, so my first step is going to be to subtract 6X from both sides. So 2 times X plus 64 equals 108, and always feel free to pause the video, try it on your own, you could always come back. I'm going to subtract 64 from both sides to get 2 times X equals 44, and then I'm going to divide by 2, and that's going to give me X to be 22, and we said X is actually equal to the length of BD. And you are done with this problem. Here's number 6. If the measure of angle CBA, this piece right here is 20, and the measure of angle DBA is 27, determine the measure of angle COD in circle O. Okay, so that gives me a lot of information. Angle COD is in circle O. So circles are named by their center, which means angle COD is a central angle, which means it's equal to its intercepted arc, in this case, arc CD. So I need to find arc CD. So let's go back. If I lead arc CD back to possibly another angle, let's see what we have. Ooh, look at this. angle B, angle CBD, angle CBD is an inscribed angle, and inscribed angles are equal to half of their intercepted arcs, in this case arc CD. So angle CBD is equal to 20 plus 27, or 47 degrees, which means arc CD is going to be twice the measure of 47, which is actually 94 degrees. And we actually just said over here that angle COD is equal to arc CD because it's a central angle. So therefore, angle COD is 94 degrees. It's like a little puzzle piece here. It's just getting easier and easier every time we do this. Number 7. Determine the arc measure of arc ED. So we're ultimately looking for the measure of this arc here. Of circle A, right, which means A is the center since circles are named by their center. And they're also telling you that BC, line segment BC with this arrow, is parallel to line segment ED with this arrow. Oh, wow, look at that. So do you guys see this letter Z? So we have alternate interior angles, right? Parallel lines, that means parallel. Parallel lines form congruent alternate interior angles. It says, and the measure of angle BDE is 65. Okay, so we have a lot of things going on here. So we know alternate interior angles are congruent. We also know that line segment BD is a diameter. And diameters divide the circle into two semicircles, 180 degrees each, which means the measure from B all the way around to D is 180 degrees. Well, guess what? Angle EDB is an inscribed angle, which means the angle is half of this arc here. So angle BDE is equal to 1/2 arc BE. So that means that arc BE is going to be 2 times 65, or 130 degrees. So now we said that arc BD, the whole entire arc, is 180 degrees. So if I take arc BD plus arc ED, right, that's going to equal, arc BE, sorry about that, plus arc ED will give us arc BD. So that's where I'm getting this from. Arc BE is 130 degrees because the inscribed angle is half of that arc, plus arc ED is going to give us 180 degrees. So 180 minus 130, we're going to get arc ED to be 50 degrees. And I am going to end right here, and I'm going to start up on the next video. So please finish up your notes here and click on part 2 to finish up your review of Unit Circle 12.